In this video, we will see dry run of the code.
Now let's quickly do the dry run of this code. So I have this maximum path sum. I hope this is clearly visible. I have this maximum path sum. In maximum path sum, I am taking one max variable. So I will take one max variable with minus infinity. Okay. Then I have one Kelsey function. Okay. And I am calling Kelsey function with root and I am returning maximum. So let's call Kelsey function, that is C with root minus 10. So I am calling C with root minus 10. Okay, I will come here. Is my root is equals to null? No, it's not null. I will calculate the left sum. Left sum will be max value of 0 and Kelsey root dot left. So again one function call here. What I will do, I will call the function, that is C9. I will call one function C9. Again I will first execute, is my root is equals to null? No, it's not. Okay, so I will say left sum again calculate. So left sum will be Kelsey root dot left. What is root dot left? That is null. So I will call C with LC with null value. Now I will say if root is equals to null, yes it is null, return 0. So I will return 0. So here I will return 0 to null. Can I say, right, if I am returning 0 here, that this function work is done, right? So yes, its work is done. It will simply remove from the stack. So it will return 0 here. Okay. Now I will calculate the right sum. Right sum will be 0 plus LC root dot left. What is root dot right? That is null. So again I will call one function C with a null value. C with a null value. Now root is null. Again I will return 0. So this will also return 0. Right? So here left sum is 0, right sum is 0, and maximum is also 0. Can I say my C9 is completed? So I will remove from the stack, right? And I will remove, let's make it in the binary, but we are here. Okay. Now I will calculate the maximum. Basically, I will calculate the node value. So it will be root dot val. What is root dot val? That is 9 plus left sum, that is 0, plus right sum 0, and maximum. So maximum is minus infinity, and you are getting 9 plus 0 plus 0, that is 9. So which is maximum? 9 is maximum. So you will update with the 9. And now you will come here and you will return left sum and right sum maximum, right? So what is left sum and right sum maximum? Here for this node, 9, for this node 9. Okay, both are 0. Both are 0. So basically you will return 0 plus root value. That is, you will return 0 plus 9. So here you will return 0 plus 9. It is 9. Can I say my work of this C9 is done? Because all these 4 lines are executed now. So C9 is done and I am returned from it. So yes, C9 is done. Right. Now after this, I will be here because left sum is calculated, right? And it is positive. It is 9. We are getting 9 here. Okay. Then I will call right sum. What is right sum? I will call C20. So I will call C20 here. Okay. So I will call right. I will check, is the root is equals to null? No, it's not null. Again calculate the left sum. Again call root dot left. So I will call this one. That means I will call C15. I will call C15. Okay. Now again, is 15 is null? No, it's not null. Again calculate the left sum. Again call root dot left. What is root dot left? That is null. Right. So here the root dot left is null. So basically you will return 0. So I will return 0. So C16 will call to Cn. Right. I'm not writing it. That is Cn. Cn will return 0. So basically from C16, sorry, C15, it will return 0, right? The left one. Okay. Now I will calculate the right sum. That will also return 0 because null. This is also null. It will return 0. And you will calculate maximum. Maximum will be root dot val. What is root dot val? That is, let's see. What is root dot val? That is 15. What is left sum and right sum? That is 0 plus 0. So this will be your new sum, right? And you will update with the max. So 9 and 15, which is greater? 15. So you will update with 15 max and you will return left sum and right sum max. Both are 0, right? Plus root value. So you will return here 15. Here we have returned 9. Okay, you will return 50. Again from C20, right? We are here, we have calculated left sum, right? Once we backtrack, we will come here, right? And I will call the right sum. What is the right sum? I will call this function 7, right? So I will say, I'll call C7 and C15 work is done. So can I remove from the recursion stack? Yes, I will call C7, right? So once I call C7 is 7 is null. No, it's not. Again, I will call root dot left. That means I will call null. It will return 0. Again, I will call right sum. It will call null. It will return 0. I will find out met.max root val plus left sum plus right sum. Basically, I will find 7 plus 0 plus 0. That is 7. Is it greater than 15? No, it's not. So I won't update it. And I will return left sum and right sum max. Both are 0 here. And plus root dot val. So basically, here I am returning 0 plus 7. So here I will return 0 plus 7. That means now see. Now you have a left. You come back to C20, right? C7 is done. C7 is done, right? So after C7 and C20, you have calculated left sum and right sum. What is the value of left sum? Basically now that is 15 and here you have 7. So again you will calculate mat.max. What is mat.max? Root dot val 20 plus left sum that is 15 plus right sum that is 7. So you will calculate this one and you will find out the sum. What it will be the sum? 42. You will check with the max. Yes, 42 is greater than 52. 15. You will update it and you will return the max of left and right. What is max of left and right? That is 15 and 7. 15 and 7. 15. Right. So you will return 15 plus root value that is 15 plus 20. So you will return 35. So see, I am taking this path. Right. Not 2 lines, but yeah, this path. Now see. Okay. So basically, can I say my C20 work is done? Basically, it returned 35. So yes, C20's work is done. I am executing C minus 10. So now execute C minus 10. C minus 10, we are getting 9 from the left. We are getting 35 from the right. I will calculate mat.max. What will be the mat.max? Root value. What is root value? Minus 10 plus getting 9 from left, getting 35 from right. So it will be 34. Is it greater than 42? No, it's not. Okay, 42 is greater, so max will be same. And I will return the left sum and right sum max. So 35 and 9, which is max? 35. So I will return 35 plus root value. That means 35 minus 10. So I will return here from this function, that is 25. Right? Because here Kelsey suppose if return. But we don't want a Kelsey return value. I don't want a Kelsey return value. That is 25. What I want, I just want to find the maximum. And I will return maximum. My maximum is updated to 42 and that is my answer. Right? So the maximum path we are getting only this one. We break this path basically because we want 42 and we got this as in 42. Right? But we have traversed from here to here because we are calculating complete, right? So we will go till the leaf node, right? Leaf node. So basically, if I talk about the time complexity, so you are visiting each node, right? Each node once only. So time complexity will be big O of n only. And what about the space complexity? So you are going to the end node, like leaf node. So whatever the height of your binary tree, that will be your space complexity, right? So time complexity is clear, space complexity is clear. This will be your solution. Yeah, one of the very good and finest problem on binary tree. Okay. So yeah, that's all for today's video. Thank you. See you in the next video.